this movie, we use this old exam question to help us to remind ourselves about some concepts about equilibrium, as well as to get some practice with calculations pertaining to equilibrium. We're now asked to predict what will happen if various changes are made. First of all, if we change the amount of carbon, if we increase the amount of carbon, whether we increase or decrease the amount of carbon, that will have no effect upon the equilibrium. Why? Because carbon is a solid. It's pure. So it doesn't have a concentration. Concentration is irrelevant to carbon. And therefore, we are not changing the concentration of a reactant by changing the amount of carbon that is present. So that will have no effect on the equilibrium condition. Then we're told that we increase the pressure by decreasing the volume. Click on that link for the effect of a change of pressure on equilibrium. But very quickly, what's going to happen here is that will favor the reverse reaction, decreasing the amount of carbon monoxide at equilibrium. Why? Because an increase in pressure favors the direction of reaction, which causes fewer moles to be produced, because by doing so, that decreases the pressure going against the stress that was provided. Next, we're given a table of data about various temperatures and the relative amounts of carbon monoxide and carbon dioxide at each of these various temperatures. And from this data, we must deduce whether the forward reaction is endothermic or exothermic. What do we notice from this data that we're given? We notice that as the temperature increases, there's a greater fraction of carbon monoxide. In other words, a greater proportion of carbon monoxide compared to carbon dioxide. So that tells us that an increase in temperature favors the forward reaction, making more carbon monoxide. If an increase in temperature favors the forward must be endothermic, kind of mopping up, absorbing that extra heat that is being added by the increase of temperature to try to counteract that increase in temperature. So the forward reaction must be endothermic. Last, we're asked to say at what temperature our first question applied. That's why I left these values here, because they're still relevant for figuring out that answer. So you can see here that we have the relative amounts of carbon dioxide and carbon monoxide here. The problem is just they are not here in the same format as given in the table. So it makes it just by eye difficult to figure out which of the temperatures this corresponds to. So all we need to do is convert this also into percentage as the data in the table is. And then we will very easily be able to see where this fits within the table. So how do we do that? How do we convert it to percentage? Well, we need to know the total. And then all we do is we take each value divided by the total expressed as a percent. So the total is very simple. We just get that from adding the two values. 0.162 plus 2.44, our total is 2.602. Very easy calculation on the calculator. 0.162 divided by 2.602 multiplied by 100 is equal to 6.23%. Whereas here we have 2.44 divided by 2.602 multiplied by 100, 93.77%. We check the table, we see for which temperature do we get that percent ratio of carbon dioxide to carbon monoxide. And we see it corresponds to a temperature of 827 degrees Celsius. So that was the temperature T at which this first question happened. And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!